Welcome. All right, so how do you solve a quadratic using various methods? Well, that's a great question. Let me think about that one for a second. Well, first of all, before we even get to that, let's kind of talk about some various methods. First of all, when we're dealing with the quadratic, that means our quadratic can be put in the form of y equals ax squared plus bx plus c. Now, unless we have a quadratic that only has our ax squared and our c, we can use the square root method, right? Which would kind of be very similar to solving a linear equation. So the first method that I'm going to notice is square root method. And we're going to use the square root method when we have a quadratic that's in the form of ax squared plus c. Therefore, there's only one variable. It's squared, so it's in a quadratic form, but it's only one variable. So therefore, y equals 3x squared minus 5. All right, that is a problem that we can solve using the square root method, which is pretty much using inverse operations, just like we use for solving equations. You use you're undoing the operations. However, we get into some issues when we start seeing quadratics that they have the x and our middle linear term. And when we have quadratics in that, we need to start getting into factoring. All right, and there's a lot of different factoring techniques that we're going to discuss. One is going to be factoring just out a GCF. And GCFs are going to apply to factoring all types of problems, but also when we have a quadratic just with the middle first two terms. That means y equals ax squared plus bx. This way, we can just get away with just factoring out the x and any other common factor and then solving. Then when we have all three terms, we have our factoring techniques, which would be when a is equal to 1, when a is not equal to 1, we have the perfect square. Oh, I guess I should have gone with this. The square root method, ax squared plus c. Also, the other one that we can include is the difference of two squares. And my apologies, that comes in when a and c are both square numbers. So an example of that would be y equals x squared minus 9. Okay, so that's a special type of ax squared plus c when my a and my c are squared numbers and I'm finding the difference between those two values. But when we have, now let's kind of go back to our factoring technique. We could do a perfect square when a is equal to 1, a is not equal to 1, and we could look at a perfect square. Now, these techniques can work on majority of all of them, but they don't necessarily work factorably on all of them. So the other methods, which I like to kind of call our foolproof method, is for y equals ax squared. These are going to include your completing the square and the quadratic formula. So, in this problem, we're trying to identify how do we solve by using various methods. You can see there's tons of methods out here, right? And usually the first thing we always want to look into is factoring out a GCF. But not always is factoring out a GCF going to be the best method, because a lot of times when we have the ones that have a difference of two squares or the perfect square, we want to look for perfect squares or difference of two squares. And so if we're looking for square terms, sometimes we don't want to factor out the GCF just yet. We can solve it by looking for those perfect squares. However, you can still get away with it, but a lot of times it's easier to factor these by using the difference of two squares and the perfect square trinomial rather than factoring them out. But if not, then what we like to do is go ahead and look and identify, do we have it in this form? Then can we use the square root method or still use the difference of two squares? Do we have it in this method where I can use my GCF again? And then if it's in this method, can I use one of these processes? And if I cannot, then I'm going to go to my full commitment process where I can factor any sort of trinomial. So there you go, ladies and gentlemen. That is just hopefully a kind of quick little video on how to solve a quadratic by factoring using various methods. Thanks.